plumber, when undertaking a job, will record the job number and description. She also records the items used for the job. Each item used can be found in a stock list that includes stock codes and unit prices. A job may take more than one day, and the date and number of hours worked on each of the days are recorded in a work session table. So let's look at part A then. Produce an ER diagram for the record system described above. So there's a lot of clues given in that question, but this is what they want. We'll need a stock list, first of all, and we need a list of the items of use for each job. So that makes that relationship reasonably straightforward. One item of stock can appear in an items used table many times, and one job can appear in the items used table many times as well. Now the other relation is that they're all recorded in a work sessions table. So one job can appear in the work sessions multiple times. So you get a mark for each correct one-to-many relationship, up to a maximum of 3 marks there. Well, there are only 3 relationships there, so 3 relationships for 3 marks. By the way, if you are struggling with this, the only real way to get used to it is to practice it. There are a bunch of past paper questions that exist for this very topic, and if you go to the AS questions, especially the Unit 2 stuff, there are lots of the same things as well. So there's lots of practice material out there that you can use to practice this idea and keep going through it. The more you practice it, the more you get an idea of what an entity is and how that relationship works. But there's no real easy way to learn it. It is a practicing job. Part B, design a database in third normal form, our favourite, to store the information required for the record system. Okay, well, let's have a think about this then. So what are they looking for? And this, by the way, is how you would write it in database notation. Database notation is a nice way of designing a database without having to write out the entire tables. The database name is given at the start in capital letters, and then in brackets are the fields. You would have to indicate what the primary key field is and what the foreign key fields are, but you could do those with underlines or overlines or just with little symbols as they've done here. So we've got our job, which is a table containing the job number and the description, which makes some sort of sense. Our work sessions table then would have a work session ID or something similar, that's the primary key. Have a job number, that's a foreign key coming from the other table, as in our relationships, and then just a couple of select pieces of data that would be stored in there, like the date, the hours worked. There could be more in there, couldn't there, really? The stock list then, same sort of thing. It's got a stock code, it's got a description, it's got a unit price. You're filling it full of examples of data fields that you might want to ask. Then we got our items used table. So that's going to have our primary key of items used ID or something similar. It's going to have job number as a foreign key because we've seen that in the relations we've designed. Stock code is going to be a foreign key as well because that's in the relationships we've designed. And the quantity might be an obvious thing to do there. Now we get 1 mark for 4 tables. Okay, you get a mark for a table, item used, linking job and stock table. And you get 2 marks, 1 each for the primary key fields suitably identified in job and stocks. That makes sense, doesn't it? And 3 marks then for each foreign key suitably identified. So the foreign keys are really where the massive amount of marks are for this question. So it's well worth working out how this works and making sure you understand it because it is a high marking question. Now, of course, any additional fields you add apart from that will be ignored, but they're worth putting a few in because occasionally in some of these kinds of questions, they might be expecting a few. So it's always worth putting a few additional fields in if you can. Question 3 here is our SQL question, and these are always identifiable in the paper. They usually take up an entire page, and they look very, very similar to this. If you know your SQL, these questions are a bit of a walk in the park. However, if you're not too sure about them, it can be a head scratcher. So question A, write an SQL command to output the course title and degree only for all the courses. All right then, well, it's going to be reasonably straightforward. It's a select query. Select the course title, the degree from course. Straightforward. Part B, write an SQL command to output the module title for all modules available on the degree course with the course ID 427. So it's going to be a select query again. We're going to be looking for module title only because that's all they want from us, from the module table where the course ID is 427. Part C, write an SQL command to change the year in which the module Freshwater Biology is studied. This module has now been studied in year 3. So this is going to be an update query, update module table, set the year studied to 3 where the module title is Freshwater Biology. That is where the mark comes from. They would have accepted as well if you did that via the key field, which is fine, but it isn't really what they've asked for. They try and give you all the information you need for the search in the question there. So you shouldn't really have to be going to the table to look up the module ID yourself. Part D, and let's move that up to the top a little bit so we've got a bit of room. Write an SQL command to output the module title and the year studied for all modules available in the Modern Languages course for the BA degree. There's a lot of bits to this, okay? The first method, which I think is probably the most straightforward one, select the module title and the year studied, because that's what they ask for, from the module table where the course ID is equal to, and then you've got the brackets. So we've got a subquery here where this would go and do this first. Select the course ID from the course where the course title is Modern Languages and the degree is BA. So that bit in the brackets would be done first. It would end up with the name of a course, or sorry, the ID number of a course, and that would then be searched for in the first part. Remember, this is like BIDMAS in maths. It'll do the bracketed part first. So because it's in brackets, it'll go and work that thing out first, and then when it reads the query properly, it'll have information in that brackets. There's a mark for selecting the first part, so there's a mark for the first part of the query and a mark for the subquery. Also accepted though would be using a join. And a join is not in your syllabus at all, but you may have needed to use it to build your programming project. Join combines the data from two tables together by linking it on a certain field. So that's what that's doing here. Again, computer science, I think, is one of the only subjects where we get that lovely phrase, accepted but not expected, inside the mark schemes, because there are ways of doing it that are more straightforward maybe, or even more complex, but are different, and they're just not on your syllabus. So our mark scheme is full of things like that when we're on a technical thing like this. So part E then, write an SQL command to list the module title and the students enrolled for all modules which have less than 20 students or more than 40 enrolled. There's 2 marks. We've got select the module title and students enrolled, because they're the fields I asked for, from the module table where the students enrolled is less than 20 or students enrolled is greater than 40. So it's just using the inequality signs there, and we're getting a mark for the OR operations and the rest of it, really. Okay, question 8. It's an 8 marker. It's a data mining question. Difficult to answer this one unless you've seen some of these past paper questions and you understand how they're going to be broken down. So we start off with each of these points up to a maximum of 2, and then we'll have a bit more in a second. So first of all, data mining is automated analysis of large amounts of data to identify patterns. Okay, that makes sense, doesn't it? You could get a mark for the objective is to turn raw data into information, which can be used for decision making. And that's true, because the point of data mining is to take shed loads of data and identify the patterns and use that to make decisions. Now, this could be to look at like marketing trends in your business. When's the best time to advertise ice cream? Probably during summer, but I don't know that. That's me guessing. If you did a big data mining exercise on that, maybe ice cream sold better at Christmas time. I don't know. That would be a useful thing to data mine. Data mining may involve the use of statistical or predictive analysis or artificial intelligence, especially if the data set is absolutely ginormous. And then 2 marks for each of the examples. So in each case, 1 mark for identifying an organization in the data source, and another mark for then the objective of the data mining. So the sort of things you could say, an insurance company, well, what would they use it for? Well, they'd analyze car insurance claims to predict the different type of risks depending upon your age, your sex, your type of car, your occupation, your business, blah, 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 blah. There's a load of things there that the insurance company would want to look at over the course of all the claims they've ever dealt with over the decades, and they'd be able to identify if you were a particular risk based on that large data set. This is why young male drivers tend to have higher insurance premiums than older female drivers. A shop might look at the buying habits of the customers so we can advertise more effectively. The police might analyse incidents of crime in a particular location and get an idea of when the pinch points are, when they can put more people on the ground to help out with that. A health authority might analyse data on the outcomes for patients to identify the most effective medical treatments or whether screening is particularly useful. All of these things are just indicative content. If you've got a good reason that you could be data mining, you're going to get the marks here. But you do need to break that down into organisation and then talking about the objective. What are we looking for there? Question 13, explain what's meant by distributed processing and describe how this will operate using an example you've studied for 6 marks. So remember, distributed processing is processing computing tasks by sharing the load between computers in different locations. It's different from parallelization because parallelization is where we split the task up in one location. Distribution is where we split the task up between lots of different computers in lots of different places. We also get a mark for the concept that each computer will run its own programs and have its own stores of data, but will then share back the result in the network. There's probably a computer then necessary to pull that together. And then up to 4 marks for describing distributed processing in the context of our chosen application. So for instance, you might have said a patient record system for a health authority. In that case, the computer will be located in health centers and hospitals. They'll be linked in a WAN. Each computer will have the software necessary to carry out database operations. So patient records might be held locally, but additional records might be in hospital, the treatment's being provided, and doctors and other staff may have to access all that information in different parts of the network. So the overall system might just give summary data based on all that as a generic overview, and will be able to inform GPs of the outcomes of the hospital treatments. So that's one very specific example there, distributed processing, where that might be working. You probably have a more exciting example than that. But regardless, you want to make sure that you've got 4 key points there. And the best way to do that is to put a bullet point down and write a full sentence, a full unique sentence. So you can make sure you've got the marks and you don't repeat yourself. There are loads of other past paper questions to try on this topic as well.